This video is about installation and calibration of direct conversion receivers. I will show an IQ Plus and a WSE converter system with two different sound cards, a Delta 44 and a Maya 44. And first, the installation. I go to the internet and this is my home page. Here is Linrad and installer for Windows. So I click on that and run and run, and the installation is just to click on yes and next on the buttons here. And I don't want to launch Linrad. Well, yes, I can do that. And then I give the parameters and I set it up as a normal user, that's S. And small fonts, because I'm going to make fairly small screens because I will have several windows open. And normal priority. And I set the sizes as percentage, so that is N. And the width could be, let's say, 48%, and the height 60%. And then I have to click the window that opened, and you can see the message cannot open the DLL file. I have not installed the DLL package yet. So I press W to save parameters so far, and then exit, I escape, and go to install Linrad under Windows, and a little bit down here is Linrad DLL files. So I right click on that and save target as in the Linrad folder, where we already have this folder where Linrad 04.07 resides. So that's it. I click too many times. And then I have to unpack, and I use this program for that. Linrad. And then Linrad here also. And unpack this. Yes. And then I don't need this anymore. All the DLL files are in here. So I can start Linrad now and set up the sound card. That is U, and select sound card, and that is A, and use port audio, no. And I want the Delta 44 on this instance, so that is number 5. And I don't need more channels, but I do need the extensible, so that is yes. Sampling speed 96 kilohertz, 24 bits, 4 channels. And hardware, that will be number 3, because I have now the IQ Plus connected, and I don't select anything for the output, that is Z. And I have to set up the parameters for the hardware, for the IQ Plus, so that is D. And there are two alternatives, and I have to select 0 because I have been using some software for SoftRock that requires that one is using libUSB 0. Other programs might require the other, more modern interface. So that is 0. And here we are. And then I have to set the clock multiplier, that where are we? Frequency multiplier, that is I. And as you can see, for IQ Plus I have to put 2. And then I have to set the max receive frequency, that is E, and I make it 148 megahertz. And the lowest frequency I can set that to, that is a D, 142,000 kilohertz, and then exit, and exit again, press something, and then save. So now I have set up for the Delta 44. Let's have a quick look what is on the screen. I press D, can be an enter on anything, and save. And here you can see there is something. I will show later what this is, because I will first set up the other sound card. Before I do that, I will copy this Linrad installation to make things easier. So I make 2 new directories. One, Delta 44, and another one, Maya 44. And then I copy everything. Copy. And then the same with Maya 44. And copy. So now I have 2 new installations, and I want icons for them, so I have to find where is Windows Explorer here. My computer, Linrad, and Delta 44. And here is the executable, so I right click on it and send it to the desktop. And then I rename it Delta 44. And then I do the same for Maya 44. Send to desktop. Rename. And then to make life easier, I will modify this launcher a little bit. Properties. So I write Delta 44 here. OK. And then properties, and I put Maya 44 on the other launcher as an argument to Linrad. And now I can start Delta 44 and run in SSB mode, and here we are. And then I start Maya 44 and go for the setup, that is U, and I have to change the sound card, that is A, and A again, and no, and I want number 3, that's all the channels of Maya 44. Do you need more channels? No. and I want the extended format because otherwise it's not possible to have 4 audio channels. Sampling speed 96 kilohertz and 24 bits and 4 channels. And here I set undefined for the hardware and Z and then exit. And I save the Maya 44 setup and then go to SSB mode. And it's already set up because it's the same as for the Delta 44. So now we can have both of them at the same time, like this, looking pretty similar. Now I will show what the signal here really is. X, and I for sound card test mode. Enter a couple of times. And then here, X, and I, and enter a couple of times. It's a square wave. And you can see the difference between Delta 44, when it looks very much like a square wave, and the Maya 44 when there is a high-pass filter, so the square wave is sloping, and this is a fairly high audio frequency. It is 100 Hertz. So I reduced the frequency a little bit. And when the transition comes, you can see it's at different heights on the Maya 44, whether it's going up or down. But on the Delta 44, you can see that it's far more like a square wave. One can see a little bit of the influence of the high-pass filter. That means it is AC coupled, like all sound cards. And if I go for a much higher frequency, here we are, you can see the cards look fairly similar. I will open the mixer windows. Delta 44 belongs here, and Maya 44 here. I would like more gain here, but I cannot do that, so I make a little bit less gain on the Delta 44 instead. So that has to be done in hardware settings. So I go for consumer mode, and then I have to reduce the gain a little bit on the Maya 44 to make it similar. And I can turn up the signal level so it will be easier to see. A little bit more gain in the Maya 44. Oops, it's difficult to move it just a single pixel, like that. And now again, this is 1 kilohertz, so I turn down the frequency, and it's very obvious now when the signal level is higher, that the Maya 44 is not square wave as much as the Delta 44. And this is 85 Hertz. And of course we can see there is some slope on the line also on the Delta 44, but it's much less. This will have an effect on the calibration procedure. So now I will disconnect the function generator and connect the IQ Plus. There is a pulse generator connected to the two inputs of the IQ Plus with a 3 dB coupler for the same signal to both inputs. The output is connected to both of the sound cards. They are running in parallel. It might be easier to see what this is if I press W to make lines rather than pixels, and the same here. And it's not so easy to see any difference. The pulses are similar. What has to be investigated is the level that the pulses are not too strong. So I press X and then D, and I want to look at the S meter, which is a good instrument. It can be set to decibels, and I click on a frequency somewhere, open the bandwidth a bit for better statistics, and then I want to look at the RMS noise, that is like this. And I have an attenuator, so I attenuate by 10 decibels now. And you can see very clearly, oops, now it starts to adapt the polarization. This was not what I wanted, so I make X and select polarization defaults and toggle mode, that is C, and then back, that is S, and then back. And look at the S meter again. And to see better, I make the scale expanded. It's the upgoing arrow. Like this, 1 dB per division. And if I increase the signal level now by 10 dB, I can see that it goes from 81 to 87.5, so we are quite a bit saturated. So I go down 10 dB, like that. And this now from 81 to 71, but not quite. And the same here. So this is still a little bit too much signal. I attenuate 5 more dB, like this. And now it's reasonably close, so I look at the level like that, 66 and 68. Well, let's place it here, and then I attenuate by 10 dB. Oops. That reading 66 and 68, and here we have 56 and 58. This is 10 dB. So I go back those 10 dB, and this is a suitable level for the pulses for calibration of the frequency response. Before going to that, I will have to calibrate the image, the balance between I and Q. So I disconnect this pulse generator and connect instead a signal generator. The signal generator is now about 2 kHz from the center frequency. And you can see I and Q in the time domain, and you have the spectrum from the Maya 44. So I go in the Delta 44 to show the spectrum there as well. And D. So here we go. And the level is similar, about 132 decibels on the dB scale. I have to contract the dB scale significantly to get an idea about the image suppression. The image is here. Well, the mouse is hard to see but I click on the image and you can see it is suppressed by, what is it, 10, 20, 35 dB. And in the Maya 44 it's a little bit better. No, I have to compress the scale, of course, here also. And we can see it's down. It's very similar, but the difference between the two channels is a little bit larger on the image in the Maya 44 than it is in the Delta 44. And I move the signal a little bit away. Like that. And we have the same situation in both sound cards. And now I go for calibration of the image spur suppression. So I press X and calibrate, and then A. And then for the Delta 44 the same, X, C and A. So I can do this calibration on both sound cards at the same time. Calibration near the center frequency needs the signal to be in a suitable position with respect to the center frequency. So I move it, and you can see it is now well, I switch it off so you can see where the center frequency is. It's here. And I think F11 makes the mouse visible. F11. And then I put the signal back. And I want it to not be so close to the center. Like that. And then if I move it 3 kilohertz, you can see in both cases I am at about the same separation from the center. It means I'm plus 1.5 kilohertz or minus 1.5 kilohertz. So I clear the RAM, that is C, and C here. and do the frequency stepping at 3 kilohertz. And now I press U to compute the new calibration, and also for the Delta 44. And we can see they look a bit different, the two sound cards. The green track is the phase, and it changes much more rapidly in the Maya 44. And the magenta track is the amplitude difference, and it's a bit hard to see, but I can press the plus to change the scale, so you can see that well, I press minus, so you see where the 0 point is, and here I press minus, so there is where the 0 point is. Anyway, let's use this. Any other key to exit. So enter, and then enter here. And just for fun, I can step a little bit downwards, and you can see the spur, the image spur, is now very small. So this is fine. Save current RAM contents to the disk. That's S. And then X and D, and here save and X and D, and I can step the frequency now a little bit, and as you can see, the mirror image is very small. There is essentially only one signal. So this calibration was successful for both the Delta 44 and the Maya 44. I have now connected the pulse generator and rearranged the screens, and also changed to expert for the user skill. That's in order to allow the time function, the second time function, which you can see the upper track, which is white, that is power, and then the yellow is I and magenta Q from audio channel 1, and then red and blue is I and Q for audio channel 2. And then there are 4 tracks which contain strong signals, and we don't have any strong signals, only the discontinuity at the center, or the center spur, and that doesn't matter. There is a special phenomenon in the Maya 44, and I will stop the traces in a particular position where that becomes easy to see. the first pulse in the delta 44, it has almost 0 in the yellow track, and then the magenta track, which is Q from the same channel, has all the energy in 1 pixel. You can see it's just a single point. But in the Maya 44, you can look at the second pulse, which is then 0 in the yellow track. The magenta track has the energy in 2 pixels. It means it is time shifted by half a pixel. And this time shift creates a problem. I will now run the calibration routine for these 2 sound cards with the IQ Plus. So X, and I look at the parameters, and first FFT bandwidth 200 Hertz. With this version of Linrad, the calibration runs at 4 times narrower bandwidth. This is something I will change, but in this case I put 1 kilohertz here, and it will be different in the next version of Linrad. And the parameter change doesn't affect anything on the screen, but I press X and then C for calibrate and B for calibrating the amplitude and phase. And then the same for the Maya 44, X, P, and was it 1000? I think so. And it looks like this. And then for the calibration, X, calibrate, and B. And not surprising, these 2 screens look very similar. The repetition rate is very high. I will make it lower to look what happens. With somewhat larger pulses, I bring up the level by 20 dB. You can see that the tail of each pulse reaches almost all the way to the next pulse. That's not what I want, so I make the frequency lower. This is low enough. Now there is a flat noise floor between the pulses that occupies about 50% of the distance. So I go back to the level that is well within linearity of the IQ Plus, and then see whether calibration will start properly. So I press enter. Increase pulse repetition frequency or set the bandwidth lower. Calibrate and B. I have to compromise a bit. I make the signal level 10 decibels higher to see whether that helps. No. Calibrate and B. So I make the repetition frequency a little bit higher. Maybe like this. higher than this would not be good for the accuracy, I think. But I don't really remember. So set the FFT1 bandwidth lower. P is now 250 Hertz because there was this division by 4. X, calibrate, B, and enter. And now the collection of pulses starts. So I go to the delta 44 and X, change parameters. Now it's 250 here, so it's the same. X, calibrate, and B, and enter. And here we are also collecting pulses. So I will wait for a while Linrad is collecting average that has removed or averaged out the noise around the pulse. $10,000 pulses, 11 or 15,000 actually, is far more than enough. So I press U to compute the new corrections. It looks like this. The white curve is the desired frequency response. The yellow curve is the correction that has to be applied, and the green curve is the correction that has to be applied to the phase. And here you can see that the curves are fairly steep at the edges. The filters have a high what is it called? Well, it's a brick wall kind of filter. This is a little bit more critical, so I change the shape, that is M. Now there is a parabolic fall off. This is less critical. And the same on the Maya 44, that is U, and then M. And the difference between these two screens is small, but it is there if you look very carefully, which is hard if you don't know exactly what to look for. So I save this, that's Y, means accept, and then S to save to disk. And the same here, Y and S. Now Linrad is using the calibration function. So you see the screens are a little bit different now. And the significant difference is at the center. I can press plus to make it magnified, and the same here. Gain 8, so it's the same here. the phase slope is the same for the delta 44, but it's different between the channels for the Maya 44. So let's see what that means. X and back to SSB without change, that's B. And X and B. Now we don't see anything. That's because the calibration destroyed the parameters, so I make X, X, and then D. X, change parameters, and first FFT amplitude, that was 2000 before. And the same here, X, P, and 2000. And this looks very similar, but there was one more thing, X, P, and enable the second FFT. And the same here, X, P, and enable the second FFT. The pulses are now a little bit too strong. I have to reduce to make the curves white, not red. And here you can see the now calibrated spectrum. It's more flat. I can try to enable the smart blanker by pressing here, and you see it works for the delta 44. Maybe not so well, but to a reasonable extent. And then for the Maya 44, and it doesn't work at all. So this is the big difference. It is related to this problem of different timing in the two different channels, H and V. I will look into this and see what can be done to make the Maya 44 useful in Linrad from later versions. 04.07 and earlier. Maya 44 will work if you have only one channel, but not if you have two channels. The delta 44, to see what's going on here, I increased the gain of the time function. It's now 0.00097. So I increase here. And you can see, subtracting the pulse, the reference pulse, removes most of the pulse, but it leaves something very wide with an oscillatory structure. And if I remove the pulse source, you can see on the waterfall that it is the structure near the ends of the passband that are created. I can increase the gain of the waterfall to make it more visible, and then I connect again the pulse generator, and you can see that the subtraction is accurate from about, well, 10 kilohertz up to maybe 40 or 35 kilohertz. That is because the calibration was not complete. I press X and calibrate, and C, remove the center discontinuity. And 562 Hertz is excluded from the polynomial fit. I make it a little bit larger, that is L, and I make it 1 kilohertz. And the range to fit, I make it bigger, 35 kilohertz, because the filters, the audio filters in the IQ Plus do not affect the phase below 35 kilohertz. So continue, and to look at what this is, I press plus. Looks good, so I accept this, and this is good, I hope. A. Now I have removed the features near the center. I can increase the scale, that's plus, and you can see here something is perhaps not quite right. I would have liked to see the curves from the both sides to fall on the same line. I mean, there is a curvature around near the center that isn't really quite right, but I will come back to that later on. S, and then back. And now the idea is that the what is left after subtracting the pulse should be a little bit smaller. I disconnect the pulse generator, and whether this is better or not is not so easy to say. Anyway, I will try to solve the problems of the Maya 44, and then I will make a new video on the calibration of sound cards in Linrad.